Hello, everyone. I'm Syrus Akbary, and today we'll be talking about the GraphQL Framework in non-JavaScript servers. But before I even start, I would like to say hello to my mom. She's watching me from live streaming in Spain. So if you want to join me and give her a big applause. Yeah, Mom, thank you. Thank you, everyone. So mostly all the talks that we've seen today are about React and React Native. My talk is going to be a little bit different. I'm going to get a little bit deeper into backend because, oops, sorry, I didn't take this. Because backend, frontend, and backend are very related to each other. You cannot isolate backend without frontend. Like frontend, we really need data to render things, right? So how we can manage some kind of thing where everyone developing in frontend and backend are happy to work with. So I want to start telling you my love story with GraphQL and how I started believing that GraphQL is the next big thing. So let's put some context. I was working in a Django application. Django, if you don't know, is a web framework for Python that lets you construct very easily models in backend. But not only that, it also permits you to create front-end views very easily. So we were having our front-end views made by Django templates and some JavaScript vanilla code. However, for a front-end developer, they have to set up a wall server. That means also with the database for just modify, for example, a template. And we thought maybe that's not the best structure that we should have. So we migrate all the code to a React single-page application, and it worked very well. However, what about SEO? All the renders were happening in client-side, and we want to have some kind of server-side rendering that actually use our React front-end code. So how we can manage that with our current backend code, which was in Python. So we went to the most obvious idea. Just embed the V8 engine inside our backend. It's not that great? Yeah. You can make JavaScript work very easily in your backend. So after talking across all teams, because in my company, we were not only using Python. We were having a Ruby on Rails stack, also Java, also PHP. So the V8 engine could be embedded anywhere. In Java, probably it's not V8, it's Nashorn, but you can make it work. So after talking across all teams, we decided that that was a good idea. That's the path we want to go. So this is how the example look like when we first approached this problem. We just have an index view in our Django component, in our Django application, and we rendered whatever component we want, passing some props. So imagine we are Family Guy fans, and we want to render the Peter Griffin page. So we have name Peter Griffin, and we have the company Peter Griffin Fox, I guess. So we want to render that, but what happens when we want to add more data into the template? For example, we want to add some friends into my template. So the development process looks like we have to go to the component, we have to change the layout in the component for append this new data, and then we have to go back to the server to append again the data. Because if not, nothing will show. So at one moment, one question arises. Why does the server have to know the data the component needs? Is that really necessary? And not only that, what happens when the data needed by the clients differ? Imagine we are Facebook or any other big application who have clients not only in desktop, but also in mobile and other screens, I guess. What happens when we want to render almost the same view, but the same view have more or less data depending on the screen we want to show? For example, we are in desktop, we want to show a lot of different data, but in mobile, probably we want to show a little bit less, right? So with this approach, at the end, you will have a lot of logic in your view, in your Django view, and it was not very easy to maintain. So we decided that the best idea is just let the client, let the component decide the data it wants. So we will expose some models from our backend in this through some HTTP endpoints, and the React components will consume this data. So as you may guess, I'm talking about REST APIs. But REST APIs, as probably all of you know, have some limitations. We have different endpoints per type, so different URLs per type. Imagine we have a lot of types, so we need to do a lot of requests for have this data. Also, if we use hypermedia, for all the ones that you don't know what this is just pointing a URL when we have nested resources, that will mean that we have more HTTP latency. And on top of that, the pagination will only work for the global object. So what were the real consequences of using REST? When we render a page, we are not rendering just one type. A page involves a lot of different types. Imagine we are Facebook. We want to render a profile, which is a type. We want to render photos, news. And if we take the REST approach, we will end having a lot of HTTP requests. So after that, also, we need to integrate the data that we take from server. We need to integrate into our client code. So that means we will have to create flags stores if we use the flags architecture. And sometimes, you know, like the data we have in server, like the client could know in some way that. So we guess what was the solution, the obvious solution for the first 2 bullet points is just like solve the network problem, the HTTP latency problem. So just let's glue everything together in just one API endpoint. So if we are requesting, for example, just the data for a user, friends for this user, and the company, we will glue everything together in just one API endpoint. So again, this is how our development process looks like if we want to add one field or one data into the component. We have to go to a component, change the layout to use this new data, and then we have to go back to the server API to change the API again. So again, the same question, why does the server have to know the data the client needs? So in conclusion, we want to let the component decide the data it wants and resolve it in just one HTTP request. Hopefully for us, 2 very different companies try to solve this issue at the same time. We got, on one side, Netflix, who released Falcor, and almost at the same time, Facebook released GraphQL. So let's gonna research a little bit how each one is resolving the content and how we can work with each one. So for example, if we want to have the data, the following data, we want to have the username, user company, and the name of the user friends. This is how we have to request through Falcor. So we specify the data we want through some paths, and the result data that we will have looks like a JSON graph. So we just have the fields with the data we want, and then, for example, for friends, we'll have an array of references inside the same JSON. And this is how the same request or the same query would look like using GraphQL. So we are requesting a user, the name of the user, the company of the user, and the friends of the user. And for each of these friends, we are requesting the name. And if you look closely at the response, it's like the same query that we are doing, but filled with data. So a GraphQL query is just a JSON without any data. That's the keys that we want. So what are the main differences between GraphQL and Falcor? GraphQL is a query language, as you can guess. Falcor is a library. I guess Netflix took this approach because they thought it could be easier for the developers to adopt the library, because sometimes developers, we are scared of like new things, new languages, and that could be like an easier way. But sometimes developers, we have no idea what we want. Also, Falcor response, as I said, is modeled as a graph. And GraphQL response is just like a tree. What that means, actually, if I have one friend and I'm retrieving data for me and my friend, and we share one friend in common, this friend in common will be, the response will have twice in the GraphQL response, and in the Falcor response, we only have this data once. So it's more reasonable, I will guess. One very powerful thing about GraphQL is it allows introspection. And with introspection, we can have a lot of different things. We can have validation for free. And we can have a lot of different things that I will research later. Also, GraphQL fields accept arguments. Falcor paths do not. What that means? Actually, we can see as a GraphQL field is like a normal function. So we pass arguments to this function, and we can play with the content, with the function inside. So at the end, we chose that GraphQL were probably the best path to take for us. But we have one problem. There was only one JavaScript implementation. And our backend, as I told you before, was in Python. So what we can do here? Option 1, we can use the JavaScript implementation to wrap our REST API. This is a good approach, but doing this, we can lose some context. So the next option was just port the JavaScript implementation into Python so we can use natively in our backend. And that's great. Hopefully for us, some people start porting the JavaScript implementation into Python, so it was not very difficult to start with. So let's start with one example. If we are querying the user with the ID 1, and we want to get the name, company, and friends, and of these friends, we want to get the name, and we want to get the following response, this is how we have to create the schema in GraphQL. So we have the query type, which is the root object that we are querying. And this query type have a user field on it. The user field accepts an ID as an argument, which is a string, and returns a user type. User type have, again, name, company, and friends on it. And friends is just returning an array, a list of users. So this is how the implementation looks like in Python when we have to do it. So we have the user type, the query type, and we define some fields on top of that. However, if you are Python guys, you will see that that code is not very Pythonic. In fact, it's not very easy to work with. So shouldn't creating a schema really be more simple? I want to be happy to work with GraphQL. I don't want to see this like there is some kind of overhead, and I don't work like happy with GraphQL. So because of that, I create the Graphene Python framework. Graphene is a framework for Python that lets you use GraphQL very easily. That's the reason Brent did the Graphene joke. So what were the main goals of Graphene? We want to achieve simplicity. Also, we want to be fully compatible with the spec. So the same things that you could do in the JavaScript implementation, you could do it in Python too with Graphene. Also, we focus on the syntax. We focus on the way we want to use Graphene. And only when we know how we want to use Graphene, only then we implement it, and not the other way. And also, we use it and we make it better with the help of the community. So this is how the first prototype looked like. We have a user type and a query type, and we define some fields in it. We have name, company, and friends, a user in the query. Also, we define how we want to resolve the user if we don't want to use the default one. And we have ID, which is an argument. If you look closer to this, we can see that ID is an argument who have a string field on it. So it's an argument with a field with a string. This really doesn't have any sense. So we went into our second prototype. We have a user type, a query type, and this type, we remove the fields from the type definitions. So actually, a string is a string, it's not a string field, and a list is a list, not a list field. And we can reference to the own object that we are using. Also, we move the resolver into the class, so you don't need to specify all times what is the resolver, kind of like pointing that, and it's much easier and pleasant to write. And again, if you look closer, we are defining a lot of times when something is a field or when something is an argument, but in fact, it should be very obvious. So one type is a field when it's inside an attribute of a class, and one thing is an argument when it's inside a field. So we went into our final prototype. If you read closer this, you can see that it's very easy to know what's happening. And the types. We have a user type, a query type, user with name, company, and friends, and the user field in the query. So that's very easy and pleasant to work with. So what are the features of Graphene? It's very simple, concise, and powerful. Also, we have built-in relay support. So you can start playing with your front-end quite easily. Also, it's very well tested. Thanks for that, we were able to pass through the first prototype to the second one to the final version without doing any breaking changes. And the community really loves that. Like, we support our community. Also, one thing our community loves is we have automatic mapping from Django models. So actually, you don't need to redefine all your data and all your types again. You can actually just plug in there, and it will work with no effort, and also for SQL Alchemy. One thing I'm more proud of is the playground. I was wondering if I can make Graphene work in the browser. However, I have one problem. Python doesn't run on browser. What I can do here? So hopefully for me, there is one Python interpreter in JavaScript, and I just plug in Graphene into that. So you can just start playing in your browser with Graphene in the following URL. I will put an example so you can see how it works. So we create a user, which inherits from object type. We create a name on it, which is a string. Then a company, which is, again, a string. And then we create a list of friends, which is a list of self. In this case, self is just referencing the own type, the user type. And then we create the query type, which is, again, an object type. In this query type, we have a user field, which is just referencing the user type. And we specify that we have ID, which is just a string. And then we define how we want to resolve the user. In this case, just for the demo, I will return a random user, which is probably, Peter Griffin. I think just put Peter, but it's the same. So friend, Peter have no friends. And then we define the schema that is englobing this query. The schema usually also have mutation and subscriptions, but I want to keep this easy. So then, once we define the schema, we can start querying it in the browser. You can do it in your own backend, but that's much easier. So if we query it, it will actually not work because we are requesting friends, and friends is returning a user type. So we have to specify which fields we want. In this case, the name. So we got this working. Isn't that great? Woo, perfect. So again, we are going to refactor a little bit. For example, we are going to create a map of users, defining which user, which ID have certain user. And we are just going to play with it a little bit. So we change from string to integer, and we get the ID from the arguments, and then we get the user who have this ID in the table. So if we play it right now, it will return null. That's because we are not putting any ID on it. So there is no user with ID null. And in this case, with the ID 1, it's working perfectly. So this is how the demo works, but you can write any Python syntax on that. So that's great. So if we go to a real-world example, you can. How many of you have seen the GraphQL JavaScript Star Wars API implementation? Some people? OK. So if you go through the schema, you can see how just the schema has 2,000 lines of code. And that's not very easy to maintain, is it? Just the same schema made in Graphene, it only has 150 lines of code. And you can check it. It's online, it's open source, it's perfect. Yeah, I love my framework. So what are the upcoming features that I'm working in Graphene? We'll have live queries. What that means? That means that you will only query once the data you want, and your interface in any of your clients will change automatically once the data changes in the backend. So you don't need to worry about how to integrate the data from the backend to the client side once the data is changed somewhere. Like Meteor, but better, I will guess. Then we plan to add query complexity limit. So for example, you cannot make very harmful queries into the system. And we want to add Mongo engine support for these people that use MongoDB. But what happens if your backend is not actually in Python or JavaScript? I have good news. GraphQL is almost implemented in any language. If your backend is in Scala, you can use Sangria. If your backend is in Ruby, you have GraphQL Ruby, and also for Go, Elixir, and almost any language. I believe Facebook will open source at some point the hack implementation. I guess will be not very short time, maybe in a year or so. You will have to ask them. But why you should use GraphQL in your backend? Based on my own experience, GraphQL is much easier to maintain than REST APIs. Because of the introspection system, you can have one-click documentation and UI for free with no extra effort. It's not that great. Like how many time we spend just like creating documentation for our own API, and how many time we have to say to the developers how they have to use or query our data. With GraphQL, don't have to do that longer. It's very easy to query. Also, because of Relay, you can do a very quick integration with your front end. And at the end, as you don't need to change, as you, front-end developer, you don't need to go and change the backend all times you change something in the front end. The development process is much faster. It's much leaner. You don't need to go to the backend guy and say, like, please, I need this data. You can actually query it. It's much simpler. So I want to ask you one question. How many of you were disappointed of parse closing? 3, 4 people only? I were really disappointed. But when something closes, a new opportunity arrives. So today, I'm announcing Resolver. Resolver is a backend as a service system, much like parse, but with one difference. We will have live queries like Firebase, and will be built on top of GraphQL. Also, you will be wondering why is .cloud. And the main reason is because .com, .net, .io, and even .co were taken. Yeah, that sucks. So this framework is, thank you. So this framework is based on Graphene and will be completely open source. So you can either use the backend as a service that we will provide, or you can plug it in your own backend. So it's not that great. Thank you. Hope you enjoy it.